Virtual and augmented reality technologies increasingly exploit the potential of artificial intelligence. This makes the experience more immersive and interactive, but could threaten our privacy. Virtual and augmented reality are catching on more and more, in video games as well as in more formal settings, such as the workplace. The recent efforts made for the development of the metaverse, Web 3.0, which will be added to the internet we know today, therefore put the spotlight on this new technology. Artificial intelligence, furthermore, intersecting perfectly with the possibilities offered by virtual or augmented reality, provides tools and functions that can prove to be significant, initially developed outside these parallel worlds and integrated or integrable for a better and more wide use. Differences between virtual reality and augmented reality. Although they share very similar technologies, there are important differences between the concepts of augmented reality, AR, and virtual reality, VR. Augmented reality is a blend of physical and digital environments. Reality therefore extends beyond what is physically experienced towards the digital world. This happens thanks to the use of camera sensors present in our devices, through accelerometers, GPS data and more. The person who uses this kind of technology, therefore, moves and physically interacts with the real world, however accessing a parallel digital world thanks to the interpretation, by the device, of the data collected through the hardware with which it is equipped. Think of the Pokemon Go game, widely used in past years. Virtual reality, on the other hand, is a complete digital simulation of 3D images that allow those who use it to interact with the virtual world by accessing only a technological device. Therefore, the key element that distinguishes R, i.e. an overlap between the real world and the digital world, is not present. Current applications of AI in virtual and augmented reality. The field of R and VR, in the past, used only non-AI based technologies, but, recently, many companies have noticed the potential of artificial intelligence in the sector. This, especially with deep learning models, can in fact perform more efficiently tasks traditionally performed by more rudimentary technologies or by humans themselves, such as object tracking or the development of extremely detailed 3D models. Deep learning models, in particular, can help an AI or VR system interpret complex environments. The applications of the AI VR/or combination are innumerable and continue to increase. Artificial intelligence, in fact, is increasingly replacing traditional artificial vision technologies, integrating more advanced computer vision techniques within worlds of virtual or augmented reality, making the user experience more realistic and interactive. This is possible thanks to technological progress, including the increase in data storage possibilities and the enhancement of computing capacity. Among the sectors that are integrating AI into their virtual or augmented reality experiences is, for example, the aerospace sector. In fact, AI helps in the management of maintenance problems, identifying the aircraft components that need maintenance or improvements. Even in industries like retail, AI could streamline the customer experience, through the creation of virtual showrooms or fitting rooms, or by offering pop-ups of deals and discounts that appear as you walk around a store of interest. Even in the military field, AI could be integrated for the benefit of users. Think of soldiers who can carry out their training with very realistic virtual simulations. Or, in telecommunications and video games, as well as security. It is therefore not unthinkable that soon many people and companies will choose to use smart glasses, which will allow us to extend physical reality by drawing on immediately accessible useful information. For example, if you meet a work colleague, the system may provide details about that person, such as name or position within the company. The importance of data in AI-based VR/or systems. For an AI-based VR/or system to work, a lot of data needs to be collected. This, as anticipated, is done through sensors, but also with the help of social networks and other tools depending on the data of interest. In fact, it can be images as well as audio or textual content, which, in order to be usable, must be labeled and described. The capabilities of similar systems within virtual and augmented reality are numerous. These technologies, among other things, are in fact able to detect, classify and segment the objects represented within images or videos, interpret audio and recognize and translate textual contents. Google Translate, for example, is capable of translating the text within an image, superimposing, in the photo, the translation on the writing present in the real world. The more data that is collected, the more realistic, interactive and customized the environment will be for the specific user. Furthermore, several specialists are working to make the most of the potential of AI and neural networks in the construction of realistic environments. Problems and future prospects. The data collected by similar systems comes directly from our own lives. These are geolocation and biometric data, images of the world around us and audio heard in the environment in which we live. Data that makes the AR/VR experience much more immersive, but that exposes us to various risks. These critical issues, therefore, make it essential to carefully protect our privacy, through the adoption, by the state, of targeted and effective regulations. Balancing the right to privacy and the drive for innovation is not easy, but it will be necessary to develop laws that take into consideration the real risks deriving from these technologies, but which do not limit the inevitable progress that will characterize the field in the coming decades.